Welcome back. I hope everyone had a good lunch break and filled up your energy. Next up is Miho, a developer who discovered hard way that LLMs are like nuclear reactors, full of potential, but also full of potential disasters. He'll show us how he tamed a chaos of AI-generated code with smart techniques like scaffolds, validation, and a few sneaky cheats, providing that AI works best when humans are present. So please welcome him.
All right, can you hear me okay? I guess you can. So the topic of my talk will be squeezing the model. What we can do with the model to get the best results out of it. Let me see. Click, no click. Let's try this. Click, no click. So please stand by. Yes, nice. Okay, so a little bit about me. I'm Miho. My first programming language was Logo. It was, if you maybe heard of it, it was this turtle where you draw shapes with it. So I kind of stayed in the team with the front-end development. I like contributing to open source. I freelanced, I worked at enterprises and startups, and my latest gig is WASP. I'll tell you a little bit about WASP later. And one of my fun activities I like to do is scuba dive. Catch me later if you wanna nerd about scuba diving. Okay, so today's talk we're gonna start with the story of Magic App Generator, or Mage for short. It was a tool that my team and I built back in 2023. The idea was, can we build a functioning full-stack app with the tools that we had at hand. So what did we want to do is generate full stack apps with the client, the API, and the database all included. And when we built Mage, it was one of the cheapest way to get such results because of all of the interesting techniques we found along the way. So the context of the time, 2023 July, if you all remember, is like GPT 3.5, GPT-4. So kind of what we were working with was this, GPT-4 was good, but it was slow and expensive. GPT 3.5 was quite a bit faster, quite a bit cheaper, but it wasn't the brightest bulb. It wasn't the brightest model we had back then. So at the time, most of the things that people were generating were some sort of interesting HTML demos. Where you could ask ChatGPT to give you some HTML code. Hey, make an interesting demo of like a spinning circle, a triangle spinning. It was all very interesting. But when we wanted to do something full stack, we kind of hit the limits of the models because it wasn't very good at first. We generate the app and this is what happens. It's white. Of course, there's a front-end error. Okay, let's figure it out. There's a back-end error. What's going on? Then there's a schema error. What? Now we kind of patch it up, but it won't load. The input is missing. So we were like, what? Come on, this can't be this hard. And of course, over like a period, I would say 6 weeks, we kept at it, and voila, we got full stack apps. And we were very pleased with ourselves because you could enter a prompt, get the client, the server, and the database all working together in a nice harmony. People started building all these various apps, like internal tools or some sort of weird idea that had at the time, and the thing kept working. I think there was like around 40,000 apps generated in 2 months, and we had quite a bit of fun, checking the analytics and what was generated, who was pushing the limit next. Admittedly, it didn't generate the prettiest apps, but we successfully built a system around GPT 3.5. So what we did to get to these functioning apps, we had some techniques that we developed. But instead of me talking about these techniques, I thought, let me show you. Let's do something together. And for this, I say today, we'll take a cheap model. I picked GPT-5 Mini. It's quite cheap. And let's build a full stack app generator. So kind of why do we want to do this? So there is like an interesting thing going on in Australia. I think every year I could be wrong, but it's called Shitbox Rally. And if you don't know, Shitbox is kind of a bad car. And the idea is you take a bad car and you drive it across the desert. And it's fun. People are helping each other out, fixing up their cars as they break down in the desert. But it's all for a good cause. They are gathering money for, I think last year was cancer research or something like that. So this is our Shitbox Rally. We are going to together explore all the techniques that we found back in 2023. We have a Vibe engineered demo tool. I spent quite a lot of time on it, and I feel like Vibe engineered is a better term than Vibe coded here. And I stayed quite a lot of nights up until 3 a.m. And kind of this is what my friend sent me the other day. Is like this was me definitely. Like having all these models lined up and me being like, okay, now you made a mistake, now fix it. And so today we're gonna try to. We need an example app. What are we generating? Let's call it pull request tracking app. So this is a thing that me and my team had issues with recently because trying to stay on top of pull request reviews, who is waiting for a review and so on. So it's a fun thing to explore. It might be even useful. So let's start with the bare minimum. Get a prompt, give it to the model, and expect to get something out. Of course, we have to give some tools to the model. And I hope you're all familiar with tool calling in LLMs. Basically, it's a structured way of asking LLM to do something, where we give it like a way to write files, read files, and generate, see the file tree. Of course, before we can start, I mean, the model can't do all of this work, what we wanted, a full stack app from just this pull request tracking app. Of course, we need a system prompt. So we devised a system prompt. We were very, very patient with it, tried to craft it so it makes sense. And we have some stack. We are using React, we are using Express 5 and Prisma as the ORM of our choice. And it's very, very well defined in the system prompt. So on to the first demo. We'll open now the Vibe engineered demo tool. And on the left, you can see, oh, you can't see it, sorry, I just realized. So how do we do this? I move this tab here, maybe? Yes, nice. Okay, so this is the demo tool we have at our disposal. Now I can't, okay, I'll look here down. So bear with me. We can see the actual prompt I gave it. It's a little bit more elaborate. It says loads data from GitHub, loads PRs, shows a list of PRs, etc. And we are saying it needs to have some sort of auth. I picked the simplest one to just keep things a bit easier for the model, username and password auth. And what happens in our demo tool, which has this nifty replay mode, and I hope it works because, oh yes, okay. What it does, it starts code generation right away. It takes the system prompt, it takes the user prompt, and just starts writing files. It takes some time for it to actually return the call. Yeah, it's done it. And what we can see is it actually generated the app in the structure we described in the system prompt. So this is, I won't go too much into this bit. There are some more interesting demos ahead. But in a nutshell, it got the job done. The app, I'll try it. I'll click run here. So the demo tool also has a Docker container spinning in the back, and it runs the actual app. Oh no, okay, good. Whew. I thought we didn't have cached NPM dependencies on this Wi-Fi. This would have taken some time. You see some errors already because it didn't get everything quite right, but the front end is at least there. Okay, not the prettiest one. That's fine. We don't care. But yeah, so what happened when we did this? Okay, let me click here, click there. So in our example, we saw the model took the prompt and just wrote a bunch of files. Okay, so that's the baseline. It wrote a lot of boilerplate code because it had to. It had to write the TypeScript config. It had to write the Vite config. Everything else that was needed to get the app functioning. So we'll talk about token waste later. Right now, I think the app didn't look very thought through. It wasn't like the complex app I wanted it to be. Like so, the first thing we did when we built Mage is asked GPT-4, we cheated a little bit, to come up with a plan. We thought, okay, one call to an expensive model should be fine enough to actually get a good plan. And what is a plan? Plan is basically asking an LLM to give us a structured way of how it sees our app on a higher level. Okay, what do you think the database model should be? What are the API routes you think our backend should have? What are the client routes, and so on? You can read. A database model, it has some fields, it has some attributes, some descriptions. API route is described in this way. I always think about it like, imagine somebody asks you, hey, how do I build this sort of app? And you close your eyes and think, okay, you're gonna need this database model, this API. Basically, this is what the model is doing for us at this point. Okay, demo time. We're gonna open a different, okay, of course. So we'll have to do this each time, but don't worry, I'll get good at it by the end of it. So here I just want to show you what it does when we enable smart planning mode. This is how I coined it here. It generates planning. Okay, it generates a plan. So not to get too deep into what it generated, but the JSON you saw is nicely visualized here. And it said, okay, for this app, we're going to need a lot of endpoints, it seems. We're going to need around 5 database models. And again, the specifics are not really important. You see some models, great, the plan succeeded. One thing you'll notice is the model generated now is quite a bit more complex because it thought out the whole app a bit more. And I think it's getting us, it spends more tokens to get it, but it gets us closer to the ideal app we want. We don't want the simple, hey, put this is a placeholder, you implement it kind of solution. We want it to go all the way. Okay, so this is us coming back. And so I already mentioned token waste or token spent 2 times already. So one of the things we realized is, why do we need the model to generate the boilerplate? We don't need it to generate the boilerplate. We already know the shape of our app that we need. So why not just give it a skeleton to start with? You know, the Vite config, the Express basic setup, and whatnot. So in this case, our skeleton app is called Vite full stack base, and it looks very familiar because it's basically the same kind of structure you saw earlier that the model generated, but now the model doesn't need to generate all these files. So the client, the server, and the Prisma example schema. So it knows where things should go, and there's like a root package JSON because it's an npm workspace with all of these different bits interconnected. Demo time. So every second there's a new demo being born, and we should be happy for it. Okay, demo. So this is a very quick one. One thing which happens when we say, hey, go with a template base, is the system preloads the template. So it here says template loading. Okay, with full stack base, just like you saw on the slides, and it preloaded the app with the files. And let me just start the replay real quick. So one thing you'll notice, you can see the count of files, like immediately as we started, 16 files are already there. That's the base. Okay, nice. And then a curious thing happens. I mean, if you think about it, it's a little bit, it's not unexpected, is a model starts reading files now. Because now it knows there's something already there, and it tries to figure out, okay, my assumptions are this, and I need to look at the actual file to see what is there. And this happens for a while. It reads a little bit and then starts writing. And again, because it's the plan mode, we also have quite a bigger app because now we have both modes enabled, planning and template base. But the model did not have to spend tokens writing the boilerplate. It just had to read them, which are considered input tokens, which I'm not 100% sure, but they should be cheaper than the output tokens for GPT-5 Mini, which is a nice win for economy. And yeah, okay. So with the topic of templates, there's a similar technique we also noticed, which helped us to go the extra mile with the full stack generated apps, is pre-made blocks. So we realized there are things that keep repeating in full stack web apps, like auth, like async jobs, like, I don't know. Oof. I should know this, I'm presenting. But there's like an RPC layer that you always need, like how the client connects with the server and so on. So why not give these blocks to the LLM? But these blocks are optional as compared to the template. We don't always need the base. So we give a new tool to the model called request block in our case, where it can, based on the user prompt, it can actually say, hey, I realize I need auth. Please give it to me. And I'll show you what an example block looks like. For example, this is the username auth block. It has some client code already written. It has some server code already written. And it has some Prisma schema. So this is, let's say, a well thought out auth code that we can, as humans, we try it out, we test it out. Does it look good? Does it connect? Are there any security vulnerabilities? Okay, no, great. And then we have this small package. And when the model actually requests the block, we have some metadata associated with all of these files that I just showed you. So basically, it says, hey, merge Prisma models, use the auth router, and actually use the use auth hook on the client. So this way, we give some code to the we load some code to the project and tell LLM, hey, here's how you can access it. We update the system prompt in a way. Okay, demo time. It's always a demo time. Give me a sec. You know the drill. I'm not getting faster at this. Sorry. Okay, so in this demo, I just want to show you one thing. Here, I enabled some other capabilities as well, but the important one is building blocks, which you can see here. It actually requested a block, and if I open this, so what you can see is there's one nifty thing I included in each tool call. I tell him, give me the reason why you call this tool, and when it wants to call a tool, it has to have some sort of a reason based on its thought process, if you can call it like that. It says, I want to implement username password auth with sessions and so on, as per requirements. And also it gets the, sorry, let me zoom out, and also gets the instructions on integrating those. So files copied, there are some dependencies I will need, some integration steps for you. All right, cool. So this does for us is gives us a peace of mind that auth is taken care of. Why do I need the LLM to generate the auth? It's a building block that works. It's there. It's very nice. One curious thing that happens here. Now I'll have to do with my Superman eyes, like this, to actually find the Prisma file. No, actually, I can find the Prisma file in the file browser. That's why I build it like this. Okay. One thing you'll notice on the bottom is the session model. This came from the auth block and successfully merged the session model with our own, with the schema it was building. So this is one integration point. Of course, there are others on the server and the others on the client. Okay, moving on. Give me a sec. Okay. Sorry for this a little bit. Okay, so the other thing we realized is what if we had some other tools alongside LLMs, some deterministic tools that we knew how to run, and of course, that could help us with error fixing. So one step we added also was running some checks to see what the LLM actually outputted and feeding it back to him if there was an error, maybe to kind of fix it. So what kind of checks we can run? For example, we can always type check the code. Since we are in the land of TypeScript and JavaScript, we can type check the code just to see if everything tracks. We have the Prisma compiler in our case because we use Prisma. It has really nice error outputs where it says, hey, I'm missing a relation. Or it's very descriptive and it really helps with asking LLMs to fix it. We can go even further and do some import and export validation. This is a common failure case that happened. It would try to import something as a named import versus a default import, but there was an import-export mismatch, and it's quite an easy thing to notice and ask LLM to fix. We could even validate the package JSON generated. Hey, you forgot this dependency, or you're not using type module, so it's not an ESM app, and so on. And so on. They are basically what I'm trying to say. Anything that we can parse and validate, those kind of checks we can use. So it really depends on your use case. For us, full stack apps, it's all of these things that were helpful for us. So demo time. The next thing I'll show you is how the type checking, or let's say the validation phase of our process goes. I hinted at this earlier, so I hope everyone can see this. Is it big enough? Okay, so what we have here is after the code generation phase, where the assistant was very, very succinct, done. He says, okay, I've found some errors for you. Okay, let's see. There are some TypeScript errors I found while validating your code. Cool. For example, the Prisma schema validator said it's okay. So nothing to do with the Prisma schema. It goes into the error fixing phase of our process. It reads some files, it writes some files, then it reports back, hey, a long message, and then it validates again, of course. Just because LLM says it doesn't mean we have to trust it. And this time, nice, no TypeScript errors found in the system. Okay, so one thing I will now try to, again, this is the most advanced step with all the tools. Let's see actually what it generated. And I'll try to run it, and let's see what happens. So below we can see it's creating the container, running the app. Now we're waiting for the health check. Nice. Okay, so let me log out and log in again. So it picked up the username and auth block because I enabled it, and I think the password is from 1 to 8. I already logged in here, so there is one repo already added. This is the actual repo of this demo tool, and it's synced with the GitHub API with the pull request. So I'll now do one thing that I haven't really tried. I didn't want to try. If this fails, we fail together. I just want to add another repo and see if it will actually work for a different repo. So our main repo, wasp lang wasp. Hope this doesn't fail. Okay, good. See what happens. I hope we get something. Okay, stuff. Oh, nice. Okay, cool. So we have a functioning PR review kind of thing where I can visit this. I think this is okay. I think Carlos, made this, and Martin. Quite a bit of comments, and I can write some note. I don't know. Hey, of course. I hope this doesn't go to GitHub. I haven't actually checked the code. Okay, I hope it's just there. We'll see. I'll see after the talk. Okay, moving on. Another thing I forgot. So I thought this was kind of a little bit. Okay, this is exciting to me, but not for everyone. It's like a bunch of files and code. I mean, you are developers, so you gotta like this stuff. But I thought, what if I had a present mode? And so I'm gonna activate the present mode now. We are loading the simulation, ladies and gentlemen. There are some power-ups we're gonna need. And vibe code, so we load the template. As I already mentioned, we are planning the architecture. We saw the plan already, so there's quite a bit of API routes it needed, and quite a bit of client components it needed. Let's give it a sec. Yeah, it's a big app. So just to recap, so this is the planning phase we saw in the presentation, which made the LLM go much wider, much deeper in what it needed. And now we are in the generating code. Oh, auth password activated. So we also use the auth password block. There are some combos, some files being created. There's a mega combo. Don't worry, it's all under control. We are now validating. I didn't go through. Let's fix the errors. We are validating again. Nice, it passed. And the app is complete. There I say, very nice. All right, okay. So that's my presentation mode. I was super pumped about this bit. I hope you were as well with me. All right. Okay, one last trick I didn't implement in this demo that we had up our sleeve when we built Mage was a higher level spec. What I mean by this, so specification of your app in a higher level. So not only like direct code, but some sort of a config where you describe what you need from the LLM or from the framework. So in our case, since we are doing WASP, and WASP is a full stack framework, we had our own specification language. And don't worry, we have it also in TypeScript. But here you can see, you can say, I need Google, or I need GitHub auth, and the WASP compiler will generate that code for you in the background, and you don't need to really worry about it. So this is a very nice fit for the LLM, because WASP itself is a compiler-driven framework. So if there's something wrong in this specification, we can say it, let it know. We can say it to the LLM, so we can maybe fix it. Also, as you can see, there are pre-built blocks here. There is the template part where the actual WASP is a framework itself. So not to dwell too much, but WASP as a framework has a compiler, takes your specification, takes your React components, Node.js, and it generates a whole package out of it. It stitches everything together. I like to think WASP as the glue. So yeah, enough about WASP. I just wanted to know it was like our secret sauce thing for Mage, because we had a higher level specification, we had a language. I couldn't really rebuild that thing for the demo. I'll be building a WASP computer, I know, a Hornet or a bee. Yeah, WASP is a terrible name. So yeah, okay. Let me step back from WASP for a second and just go into the general thought. In more general terms, let's talk about frameworks, how they aid LLMs. For example, in Rails, you define a whole lot of things with just these resources photos. If you're not a Rails developer, but it's quite simple. You can read it. It's like human readable. So resources photos, and you get all of these backend routes in return. So this is quite a nice way to simplify things for LLMs. Laravel has a lot of pre-built blocks. For example, this is how you dispatch jobs in Laravel. This is all the code the LLM doesn't need to write. For example, one of my favorite frameworks lately was 10-stack start. It's the full stack framework. It handles the server and the client. It thought the connection through. So if you ask LLM to build with 10-stack start, it's more likely to succeed because the whole full stack setup is already there. A question on your minds might be, has the meta changed since 2023? Are one-shot generators dead? So you can actually see me here developing this demo tool in 3 separate Claude Code sessions. And I had quite a bit of fun doing it. It was quite powerful. It was quite expensive. So that's one deterrent from using Claude Code for all of this kind of work. But I don't think there is replacing the joy and the thrill you feel when you have an idea, you input it somewhere, and you get some sort of a preview. It doesn't have to be perfect, but it's a front end, or it's like an almost functioning full stack app. You say, oh yeah, this could be a thing, and you take it and you maybe start building on it. I think it's a great motivator, a great unlock for people when using these one-shot app generators. And talking about them, I don't think Bolt, Lovable, V0 are going anywhere because they are quite powerful. And one interesting thing that for me is to observe what they are doing now, what is similar to what we did back then. Is, for example, Bolt has the planning mode. Of course, you gotta have that to think things through. They now have their own database service. Before they had direct, like branded Supabase connection, Stripe connection, and so on. So pre-built blocks in a way. And of course, Bolt also uses templates. V0 uses, for example, pre-built components in ShadCN, which makes all the apps that it generates look quite nice, quite beautiful, a little bit uniform, but you can, toggle some switches and get it looking nicer and more on your brand. So I think these one-shot generators are here to stay. So one takeaway from all of this that I've been talking about, the Mage story, the demo tool I've been showing, all the different quirks it does. I think LLMs in a human design system is the best way to extract value, because even though LLMs are getting more and more powerful, the models are more and more smart and using thinking mode and so on, I think LLMs can't be trusted 100%. The code they generate is still, volatile. For some security, for some security focused applications, you can't really trust an LLM. But what you can do, actually, you can help it with some deterministic tools you have in your disposal. You can give it pre-built blocks, so the work that LLM has to do is much less. Like the most precise thing the LLM can do is not to do anything if you already pre-built it. And yeah, build it into a system. So that's kind of my talk. So thank you, Belgrade. Thank you, everyone.
Thank you very much. Now it's time for questions. So again, you can either raise your hand or just write it down in the application.
There are some saucy questions. I'm up for it. Go.
Oh, here.
You mentioned it was expensive using Cloud Code. Did you use pay-as-you-go?
Yeah, that was a mistake.
Yeah, how much did this demo app cost, roughly?
How do you say a big number without saying the correct number? We got some credit from Anthropic as a startup, but it was like 3 figures, so like more than 100 USD. So the 100 USD plan or 200 USD plan would be worth it in this case. And I again spent quite a bit of time refining it, and I can talk about my process afterwards. But it was interesting getting constantly asking him, okay, now review this code that you have just written, and that improved the quality significantly. And I had like 1,000 unit tests. I know they might be all bad, but I instructed him, okay, cover these all cases, and I hope it implemented them correctly, because it kept tripping up on those unit tests. So they were doing something. So this big system was very fun to build. So, but I don't trust the code. I'm not sure I want to open source this this kind of demo tool.
Thank you.
Thank you. So is there any more questions?
Similar question. What is the cost of the full stack app that you are now building? So with your tool, like in total? I saw that some cents in some presentation, but in total, what would it be?
Here we are talking about 2 cents for this one.
For the whole application?
Yeah, well, everything that Model did here was 2 cents.
Okay, thank you.
So quite a bit. I'm not saying it would be much cheaper if we just prompt engineered, much more expensive if we just prompt engineered it, but it wouldn't be as good, and it's much cheaper than using Cloud Code for like opening a VPS, installing Cloud Code and letting it run for like 48 hours. That's a very expensive thing to do. Okay.
We have one up there.
Ooh, that's an interesting one. I have to be honest, I haven't really thought about this tool beyond this presentation, but I think it's quite interesting to explore what LLMs can do. And for example, I can answer this maybe in this way. When I work with Cloud Code, branching became like my superpower, because I had to wait for 20 minutes for it to do something, and then I was like, okay, what if I asked it to do something else in the same branch, and then like the 2 instances killed each other? Okay, now I need a different folder, like git work trees. And that's when I ran like multiple sessions. I asked one Claude, hey, analyze this problem now I found, analyze this previous session, find ways to improve the prompts, and now do 3 different things. Like 2 were read-only, 1 was actually implementing. But again, branching would be super powerful, because then you can try out different directions. And yeah. Thank you. Thank you. Yeah, now you're making me wanting to open source this. No, don't do it. Yeah, I have to review the code. But yeah, it will be quite interesting, to open source maybe a part of this, at least the shell or the UI. Yeah, please.
One question about creating context. At the beginning, it is easy. You create architecture, you create the skeleton, but later on, when you ask question about something, some issue, how you actually decide which context you will provide to AI.
Yeah, so this is one thing that I did mention when I talked about Lovable and other tools. This is one thing that they have that this doesn't. So there is no user interaction after it's done. So there is no like iteration on the app. But if I had to, if you let's do it now. Let's think how we're going to do it. I think definitely some sort of like a summarization of the code base needs to exist. The tool in this case, for example, there is one thing similar to that here, where when we start from a template, the first thing it tries is just read files. It goes after a file after a file. So that's not very efficient, and I've noticed it tends to get stuff wrong. It thinks it understood, but it didn't. So one thing would be kind of have more diagnostics about each file. For example, it being TypeScript, what kind of exports does it have? I don't know, what is the intention of this file? Kind of this metadata could help this tool.
Kind of code mapping.
Code mapping, yeah. Again, deterministic tools for the win, I guess.
Thank you.
So thank you everyone for all the questions. Unfortunately, we do not have more time, so stay tuned for the next session.
Thank you, everyone.